Greetings and salutations. Welcome to this lesson. Sorry I can't deliver it in person, but hopefully you find this version just as entertaining. We're going to be factoring in order to solve some quadratic equations again, but in this case we're going to be using something that's called parameterization. Sometimes it's also referred to as u-substitution. That's with a u and then the word substitution. It's called that because we can replace one expression with another to make things a little easier to look at, and that is the act of parameterizing. If you look at something like this expression, we notice that there's a common feature of it. Specifically, there's this x plus 3 that repeats. Because there's this x plus 3 that repeats, we can actually replace it with a variable of some other type. For example, the letter u. And if we do that, then this is a u, and that's a u, and then we have an expression that's, again, a little bit prettier. It's something that we can manage a bit more easily. So that idea is going to be used in the examples in this lesson, all four of them. It is very necessary that we have a let statement. We can't just introduce this letter u without there being something backing it up. So if we're solving an equation like this, and we notice that it has a common expression as a part of it, we can start with that let statement where we'll say that we'll let u equal x plus 3. We're letting u equal that thing that actually is common. In doing so, we can rewrite this equation. Instead of 2 times x plus 3 squared, it'll be 2u squared. Instead of adding 5 times x plus 3, we will add 5u. And then that negative 3 at the end just stays same. This equation over here is much more directly easy to solve. We can just straight up factor that expression and then break it into cases, and we'll get 2 possible solutions for u. That we're familiar with, so we do that. We factor 2u squared plus 5u minus 3, and we get something out of it looking like this, if I'm not mistaken. And as we're familiar, that gets us 2 possible cases. Either the first factor is equal to 0, or the second factor is equal to 0. And we can solve each of those cases. In the first case, u is equal to 1/2. In this other case, u is equal to negative 3. And we're tempted to say, boom diada, this thing is done, complete, super duper. But be careful. We are not actually done. Our task here wasn't to solve for u. Our task was to solve for x. U is just a variable we introduced for funsies. So in order to actually solve this, we need to unparameterize this. We need to sub back to what we had. U is equal to x plus 3. So we're going to replace all these u's with x plus 3's. So x plus 3 is equal to 1/2, and x plus 3 is equal to negative 3. With that being done, we can isolate x, and subtracting 3 from both sides, or 6/2 if you will, x could be negative 5/2 in the first case, and in the other case, x could be negative 6. And now this one is complete. I'd ask if there are questions, comments, concerns, but this is a one-way interaction, so I guess not really an interaction. But enjoy the video itself anyways. But give this next example a try. And there's a couple examples on the next page as well. So if you're really feeling daring, give all of them a try. Before you do, just quick note about example D. Somebody made an forgot to make this actually an equation. So just make sure you add this equals 0 business to it so it's actually an equation that can be solved. At this point, I'm going to encourage you to pause this video for a solid, I don't know, 6 minutes while you try all those next examples. And then, and then while you do, try the examples. If you're feeling uncertain, leave yourself some space to have a record of what you did, and then what the actual answer is if it differs. And if it doesn't, then super duper pooper scooper, you're nailing this. And then of course, once you've done all the examples, you can play with the worksheets. Again, pause this video now. Welcome back. Congratulations on not just pausing, but also unpausing. We're going to try this next example. Let's see if you get the same answers that I do. The feature we see here is that there's a common x minus 2. Very key that those are actually identical. If they're not, we can't use this parameterization method. So we can let u equal x minus 2. And if we let u equal x minus 2, we'll replace all the x minus 2's with u's. So then we actually have 2u squared minus u minus 10 is equal to 0. And we're just going to factor that from there. In this case, still a 2u and a u. Looks like we want to go minus 5 and plus 2. In which case we could have 2u minus 5 is 0, or u plus 2 is equal to 0. Oh, sorry about the messiness. This iPad has seen better days. In any case, we solve both sides, or both branches here. First branch says that u is equal to 5/2, and second branch, u is equal to negative 2. But we are not done. So we replace the u's back with what they represented. Each u was actually an x minus 2. So x minus 2 is 5/2, or x minus 2 is, oopsie daisies, is negative 2. And from that, we can get our two answers. Adding 2 to both sides, x could be 9/2, or x could be 0. Interesting. And that's that one done. I'm going to leave it on the screen for a moment while I take a sip of water because I need one. I mean, granted, you could have just paused if people are still writing. Hopefully everyone's done writing. I could insert a funny joke, but I don't know any. So we'll just go to the next page. Example C. Does anyone feel like they know what we should start this off with? Any hands? Any hands? Yeah? Quick, everyone say it at once. That's right. We are going to start this off by introducing u. And then we can rewrite this whole equation and say we've got u squared plus 4u minus 12 equals 0. And again, we factor. That's, looks like u plus 6 and u minus 2. We break into our two cases. U plus 6 is 0, or u minus 2 is 0. Which means that u could be negative 6, or u could be 2. But again, we do have to sub back. It was never u, it was actually x minus 4 in disguise. So we take off its mask, we reveal it to be what it really is. And that means that since x minus 4 is negative 6, x could be negative 2. X minus 4 equals 2, so x could be 6. And that's that one. All done. And then there's this last one, which looks kind of fun, especially because it is actually an equation now. Once again, we really should be making sure we check on this thing that's in these brackets. If it's not the same, if one of these said something like, I don't know, half x plus 7, then they're different. We can't parameterize that. Or minus 2, again, different. Different doesn't work. But they are same. So we will let u equal that same thing, half x plus 1. And then this looks much nicer. 2/3 u squared plus 2/3 u minus 4 equals 0. And then we should probably factor this. Ooh, I've got 2/3 of a bunch of stuff. U squared plus u. 4 divided by 2/3, that's like 4 times 3 halves, which is 4 times 3 divided by 2. Huzzah! I've done it. I'm a wizard. And we factor that just a little bit further. And now we can break into cases. It's possible that u plus 3 equals 0. It's possible that u plus 2 equals 0. And each of those gets us a particular solution. Done. Haha, just kidding. U is equal to half x plus 1. So half x plus 1 is negative 3, or half x plus 1 is negative 2. If you can jump straight to result from that, that's okay in a case like this. For me, my head needs to see this worked out step by step. So I'm just going to actually subtract 1 from both sides. Wait, is that what it was? Sure it was. Half x plus 1. Wicked. Oh, sorry. Somebody made a mistake earlier. It was me. It's this factoring step. So that should be u minus 2, which kind of changes some of these answers. Do. So just note, I change that to u minus 2, which means that u equals positive 2. My bad. But again, let's just work it from here. And if you can jump straight to answer, x equals whatever it equals, neat, super, swell, splendid. I'm still going to go through the process of subtracting 1 from both sides, just because I kind of need to see that right now. Half x is equal to negative 4, in which case x is equal to negative 8. Or half x is equal to 1, in which case x is equal to 2. Do be careful when you have half of x is equal to something. Remember what's required to actually isolate x. You need to multiply both sides by 2. I do see it as a common mistake that people get to this point and then they say they're going to divide by 2 on both sides. They're like, no. You're already dividing by 2. Undo that. Go the other way. So watch out. I have seen it many times. But don't let yourself be the next time I see it. Anyways, that's all the examples. It's been pretty wicked. I hope you enjoy the whole entire rest of your day. Suggested practice is, oh my goodness, it's super blank. There is textbook stuff you can play with if you do want to play with textbook stuff, but I strongly recommend the worksheets. So give that a go, give it a whirl, give it a shot, give it a stab, give it a try. And reach out to me on Teams if you have questions. And then we'll move on to the next lesson in our next class. The end.